so the last thing in 4.2 that we need to talk about is how to graph the exponential functions. We have 2 more graphs, and then you will have the whole story for the semester. We've got conic sections, the linear equations, parabolas, all various types of equations. And we have 2 more to go, the logarithmic and the exponential functions. So 4.2, you're graphing the exponential functions. And then we're going to flip that and do the inverse in the log in the next lesson. But anyway, I want you to think through the t-table, plug in some numbers for x just to get some values. Plug in 0. What did you say for y equals 2 to the 0? It is 1, right? Anything to the 0 is 1. And that's actually the critical point on your exponential graph is the point 0, 1. Because it wouldn't matter if you were doing 3 to the x, 10 to the x, anything, a fraction, decimal, whatever. If you plug in x is 0, the y is 1. So again, critical point for exponential functions is going to go through 0, 1, unless it's shifted. We have like a +2 here that shifts it up and so on, but the basic one, always 0, 1. When you plug in 1 for x, y equals 2 to the first. So what did you get there? 2. So over 1 up 2, that's another basic point on your graph. Whatever your base is, when you plug in 1, you get that answer. So 1 and then your base A. When you plug in 2, y equals 2 to the second. What do you have for that? 4. So over 2 is up 4. 2 to the third, 8. So this thing starts shooting up 1, 2, 3, 4, 5, 6, 7, 8. Pretty tall, pretty quick. So it grows quickly. Exponential growth, that's one of its characteristics. So definitely I can see on this side it's just going to keep going up, taller and taller and taller, sharper curve as this number gets bigger. When I plug in a fraction, let's just see some other numbers. Y equals 2 to the 1/2. 1/2 power means square root actually, so you can do 2 to the 1/2. What'd you get for that? Anybody? 1.4 is approximately right. So over a half was up 1.4, and it looks like it does go on my curve. I could do y equals 2 to the 1/4, 1.19. So 1/4, 1.1, that looks like it falls on the curve. I just wanted to make the point you could plug in fractions. You didn't just have to plug in whole numbers. You can plug in negative numbers. Y equals 2 to the -1. What'd you get for that? 0.5, it comes out to be a half. So back 1 is up a half. And then one more time, -2. 0.25. So back 2 is up 0.25. And so what's happening here, whatever I plug in, say -3, -4, and so on, when I plug it in for that, it does not equal 0. I can't get this to equal 0. 2 to any power is going to have an answer other than 0. So this is an asymptote actually. It's not going to touch 0, it's just going to hover over that. And that's the basic look of an exponential curve. So we would say the domain is -infinity to positive infinity. I can plug away any number for x, I can plug in for x, for the function, and get a real answer. But all the answers are positive. I could not get a negative answer, I couldn't even get it down to 0. So the range, we will put a parenthesis, real critical that you know it's a parenthesis, not a bracket, because especially when you do multiple choice on your final, you know, that could cost you the problem. It doesn't touch 0. So parenthesis 0 and then on out. All right, then number 2, I just wanted you to see, and I know I'll need to close up with this, but if it's a fraction base, that would mean the same thing as 2 to the -x. So if you flip the fraction, that changes the sign of the exponent. So some of your homework problems are like this with a fraction base, and some are written like this. So you need to be able to see that means the same thing. What happens, we do a t-table, everything is flipped around the x-axis this way, I guess is what I wanted to show you. It still has that 0, 1 on it. When you plug in 0, 2 to the -0 is the same thing as 2 to the 0, which is 1. When you plug in 1, though, 2 to the -1 gives you 1/2. So over here, 1 is the smaller part of it. You know, it's going downhill on this side. So it just turns your graph around, flips your graph about the y-axis. In general, guys, do you know if your x changes sign, You know, this means this. It means we've flipped it from the 02 to the x. We've changed every x value to its opposite. So what would have been over here is now flipped over here. So that's in general in our graphing. If you change the x to a negative x, it flips it about the y-axis. Everything that was positive is now negative. So it's the same graph, only coming downhill. We'll say it's a decreasing function. It still has a domain of negative infinity to positive infinity and a range that won't touch 0, and then on up toward the range. So just wanted you to see, if you use those two examples, that should get you through the rest of your homework.